All right, so please welcome to the stage Sam Dengler.
Thank you. Great, thanks for coming to the workshop. Today we're going to be looking at how you do serverless application development using SAM Local. What we're going to be doing is, what's a demo at reInvent without a cat demo? So today we're going to be building a workshop that's focused on grumpy cats. So you may not know, but there is a Tumblr for grumpy cats. It's been popular recently around the holidays. So we're going to build an architecture that's going to let us use an RSS feed of all the grumpy cat pictures that are posted on this Tumblr site, and we want to build our own application to consume these pictures and display them ourselves. So let's take a look at what that architecture looks like. Typically, if you were going to deploy this in AWS, these are the components that we would be using. So we're going to build a serverless application architecture that's driven off API calls. So what we would be doing is using our Cloud API Gateway, which uses a CloudFront distribution, to use our Lambda functions that we'll be deploying to process our requests to show cat pictures based on this RSS feed. We're also going to be having a static website that's a React website, client-based website, using our API to integrate that and show the pictures. If we were to do this in AWS, we would store this in S3 and use CloudFront to host the static website as well. So there are no serverful components in this architecture. This is sort of how we would build it. So in order to build our Lambda functions and deploy them into AWS, we're going to use something called the Serverless Application Model, which is called SAM. SAM is a way that you can describe the components of your serverless application, including your Lambda functions and accompanying resources, and use those to deploy them into your environment. The SAM specification is in GitHub. We do take pull requests and issues. And essentially, it's a YAML file. If you're familiar with CloudFormation templates, it's a form of a CloudFormation template where you describe any of the AWS resources that you would like. And what SAM does is it provides a couple of higher order function definitions or resource definitions like a serverless function. We also support simple tables for DynamoDB tables and API gateway definitions as well. So it's a very simple syntax. We describe the runtime that we have, how we're going to invoke our function, and a couple of other aspects. And when we have this definition, we can use that in order to package and deploy our code into AWS. In August, we released something else called SAM Local. SAM Local allows you to run the Lambda execution environment on your workstation inside a Docker container. So there's a really enterprising individual in the community that figured a way to SSH into our Lambda functions environment and extract the contents of the execution container. He took that and he built a Docker container based on that execution environment, and we've decided to partner with him and capitalize on his work, and we built SAM Local about that. So SAM Local is a way of taking that same template that we looked at a minute ago, and instead of pushing your code into AWS to test it, you can keep it local and test it there as well. So let's take a look at the actual code we have today. And so actually first let's see what our architecture is going to look like running locally on our workstation. So these are the components in AWS. This is what we're looking at on our workstation. So instead of using API Gateway and a CloudFront distribution, we're going to be using SAM Local's built-in web server, which will be tied to our Lambda functions running in Docker containers on our workstation. Our static website is going to be running in Node.js. It's a React-based client application, and we're going to be using these together to create a serverless development environment. So let's go ahead and take a look at what we're going to produce in the end. What I'm going to do first to kind of show you what we're going to be working towards is in my directory that I have my project, and we can see that reflected here as well. I'm going to start SAM by running SAM local start API. Actually, I'm sorry. What I'm going to do is running npm start. What's doing in this case is we have a project here that's actually going to be doing a couple of things when we start this. It's going to be starting SAM local using the command line SAM local start API and a port. And we're also going to be running the Node.js server that's going to be hosting the React application together. So we're going to start those things in tandem. We can look here and see that from the command line, it started both of these processes. And the React will actually launch an application at our port, local 3000. That's our grumpy cat React application. So what this application will do is we can hit this refresh button, and it will display a grumpy cat image. Very exciting, right? We can refresh it again. We can see a different picture of a grumpy cat. So that's what we're doing. So how does that work exactly? So we have our static website that's hosted by Node.js that's available at this port. And this application is coded to make requests against our REST API that has all the information about our cat images. We can actually, and that is actually what is our Lambda project. So let's go look at our API project. And inside our API project, we have our SAM template that we were just talking about. The SAM template is very lightweight. So we have the runtime that we're going to be running. Our Lambda function is going to be running in Node.js 6.10. When the Lambda function is invoked, we want to execute a certain file and handler within that. So that's how we describe that. Our handler is the random handler, and that corresponds to this random.js file that's also inside our project. The word random and the name random could be anything that you would like. It's important that they are the same, that's how they line up, but there's nothing special about that nomenclature. Within that file, we want to have a method called Lambda handler that will be executed. So if we switch back over here, we can see the Lambda handler method, and it has a signature. All Lambda events are triggered, are event-based and triggered with the JSON data. So the HTTP request that is made to our API will get serialized into a JSON object, into this event variable, which we can then use to make decisions within our API. We're also given a callback. So once our API is done with its business logic, we want to return information based on the success or failure of the processing of that information. And so here we're actually going to build another JSON object to send back as a response. This is built in a particular way that makes it easy to serialize it back to a HTTP response. So the Lambda function is not very complicated. Essentially what it's doing is taking this RSS feed that is local, which is a sort of a copy of what's available at this URL that's available from the Tumblr website, which is here. So it's just a copy of that is local to my workstation. The Lambda function is going to parse that file, pick a random entry, an item from the RSS feed, parse it to extract the image information. So we have some image URLs in here. And it's going to return that information along with the height and width to display that image at. So because SAM local is running its own web server, we can actually access that URL directly, or the REST API directly. So we see here that it's running locally at localhost 3001 at our /random resource. If we go back to our template YAML, you'll see that this corresponds to the get method on the /random resource. Okay? So we've described all of this in the SAM resource. All the hard work of putting the plumbing together to make this work is done for you by SAM and executed locally using SAM local. Okay, so when we're running locally in SAM local, so for instance, this API, let me show you how that integrates with the application that we've built. Here's our client application. In React, we have the ability to mention a proxy server to send our API request to, and that's how we're tying together our RESTful API into our React application. So let's go back to our application. We can actually look at the developer console, and let's refresh. Okay, and what we'll see is when we hit the refresh button, we'll actually see here that the random URL was hit. So we have a localhost 3000 /random, and this is where we see the response data. Let's see what's that. Here it is. Okay, so you see the image URL with the image and the height and width. This corresponds to the API that we've built to return that same information. Okay, so the React application is calling our API to get this metadata, and then in some React code, it's taking the results of that information and populating a image here with the height and width of that image, right? So it's not very complicated. It's how we're tying together both a local development environment for our React application and the RESTful API. So one thing that's possible when you're using SAM local with the Start API option is that we can actually make changes to the code, and it supports live coding, hot coding. So say that we want to display smaller images. We don't want to display 100% images for our grumpy cats. So what we can do is actually go into our code, into our Lambda function here, our random.js, and here you can see I've defined the size percentage of the image I want. So I can come in here and I can change this to 50%, save my file, and I don't have to restart the container that we're running the Lambda function. I can simply refresh my browser to see the results. So you can see this gives a really tight developer experience. Change some code, refresh your browser. It's a really nice feedback loop in order to do quick development and iterations. We can also refresh our application as well without having to restart it. And now we're getting 50% size images as well. So we also could support, because our React application is also running live with hot recoding, we could also change how that code is displayed. So if we come back into our React application, perhaps we don't want to respect the height and width that's coming back from the API. We could just remove those lines, save our file, and then this React application will automatically reload that code as well. And I can refresh, I get a large image, even though my height and width is listed at 50%, right? So the point here is that you have a local development experience both for your client-side application development in React as well as the JavaScript-based RESTful API as well. So outside of displaying these cat images, this demonstration would work if you're offline as well, if you're on a plane traveling home and you want to do some local development. If you do want to do that, you need to install Docker on your workstation. It works both on Windows and Macs and Linux. So you would want to do that before you get on the plane and actually run a sample SAM application to install the Docker image on your machine. But after that, you shouldn't require access to the internet for your development purposes. So if you want to go further from here, sort of next actions that you could take a look at, we just released today something called the Serverless Application Repository. So that is, let's see if we can find that. Yeah. And so what the Serverless Application Repository is if you have used AWS before, I'm going to log in here to my account to show you. It is an extension of the blueprint strategy we had before for creating Lambda functions. So when I create a Lambda function now, you'll notice a couple of things within the console. So I can go to the Lambda service. And actually, we'll notice if you do any code editing within the UI, the UI has actually changed now to support the Cloud9 interface. So instead of having a simple interface like you had before for editing code, you actually have a mini version of Cloud9, our new web IDE experience. I can also show you what that looks like inside Cloud9. So if we go to Cloud9 here, it's now found inside your environment. And here's a environment that I created earlier today. I can launch this environment. And I have an integrated test environment that gives me access to the application repository now. So if I come in and I want to create a Lambda function inside of our IDE here, inside our Lambda console, creating a new function now gives you access to the application repository. So we have our blueprints, but this now will contain access from, it's more of a marketplace now for serverless applications, right? So you'll have third parties that are going to publish their own Lambda functions and stacks that you'll be able to include in your projects. Those are also available within the Cloud9 IDE as well. And so you can use this in order to author your Lambda functions and change them as well. So here you can see we have a Lambda function. The same type of files, though, that were on your workstation are represented in Cloud9. We have the SAM YAML file. We have a piece of code that we're running. This is the index.handler file. You can see that this is the index file with the handler method. So all of the sort of aspects that we have of local development on your workstation are now available in Cloud9 too. And that's all I have for the demo. Yes, a question? Sorry?
I can actually bring you the microphone if you want so everybody can hear.
Thank you.
I was just guessing if Cloud9 is just for Node.js or there is also C#, Java, Python.
Good question. So the question was, does Cloud9 just support Node.js? No, so you can spin up Cloud9 environments. This is actually an EC2 instance with an AMI that we've created with the Cloud9 software as other dependencies for code development. So you can see, let me actually show you how I launched this project. This is actually part of our CodeStar services. So if I go to CodeStar, CodeStar is a way of pulling together the application code, a build plan, and a pipeline all together in one easy-to-build project. So I can come here and I can say, oh, I like a new project. I would like this to be a RESTful API. I like to code it in Python, and I want it to be powered by Lambda. So with just a couple of selections, I can choose to create this. Let's see, let's call this the reInvent project. And I can choose the repository and where I want to store my code. When I do that, this is a new feature since Cloud9 has been supported. I can choose how I want to interact with this new project. And now we used to have just these three options. Now you can actually have Cloud9 as one of your choices. So clicking Cloud9 will actually create a Cloud9 environment with your project already installed for you to work on. So when I look here, the project this project right here is a generated project from CodeStar that was automatically pulled as part of my Git repository. But if you look at the directory here, this is kind of small to see, but you can actually see that I have this foo project is part of my environment. And this is the code, and there's a Git repository, right? So I can actually say git status. I can say git remote-v. I can see this is the code commit repository that was created to store my code. All that is pre-configured for you as part of the IDE. So you have access to a terminal window where you can do sort of the things you would do from your workstation. But these things are also available to you as well from the new features within the IDE to test and run your Lambda functions locally to the IDE. So this is now part of the developer experience with CodeStar. So if you haven't explored CodeStar yet, I would encourage you to. It's a really easy way to get started and sort of get experience with code pipelines and sort of the modern methodology we use to build and deploy serverless applications. It is based on SAM, and SAM local is actually running inside the Cloud9 environment in order to facilitate the local development. So this is a great interface. I've just been a user of Cloud9, not for too long, but I've been really impressed at its speed and latency, how quick it feels to use. Sometimes I kind of forget that I'm working inside a browser, and I'll actually think I'm closing a tab and close the window instead. So I encourage you to take a look at it as a developer. It supports key bindings, Vim bindings. It's really configurable to the type of development environment you want. If you saw the keynote earlier today, you probably saw that it involves a collaborative environment as well. So you can have two people doing code pair programming in the environment. I have time.
Yeah, we do. Any other questions?
Kind of goes in line with that. I didn't see Go up there, but I know in the keynote they said Go is now going to be natively supported with Lambdas. Is that not part of Cloud9 support yet, or?
So I know that Go has been announced for support. I'm not. It's a little bit of subtlety at reInvent. Some things are announced, some things are previewed, and some things are released. So I believe we announced Go, but let's see if it's available when we pick our runtime in Lambda to see. So I can author a function from scratch. Let's see if Go is now available. So Go is not yet available as a runtime, but I know that both it and .NET Core 2.0 are both been announced for support. So look for those. Honestly, I don't know when. It might be the end of this year or early next year that you'll see that roll out.
Anybody else?
Does it integrate well with repositories like Maven or
other repositories
JFrog, yeah.
besides code commit?
Right.
Is that your question? Okay. So the question was, do we have to use code commit as a Git repository? You don't. CodeStar out of the box will support GitHub and code commit as the repositories. I have had other customers that wanted to use Bitbucket or GitLabs or private Git repositories.
Third-party library integrations, like let's say I have Java libraries externally, like in a JFrog.
So third-party. I'm sorry, I can't quite hear your question.
If it's a Maven repository where I have like third-party Java libraries and I want to put it in.
So how do we pull those into our project? Okay.
Correct.
So your project, so for instance, my Lambda project, my SAM project here, is a node project that has a package JSON for its dependencies, okay? And then there's the node modules that include those dependencies. This would be similar to your POM XML file from Maven. Part of the build process is to read these files and populate a directory with the dependencies. Okay, so I know in Maven there's a possibility to dereference those dependencies after deployment. really the best practice is to incorporate those dependencies in your artifact during the build pipeline so that when it comes to the deployment, you don't have a dependency on external repositories, and it's much faster actually to deploy your software. So what you would do inside of the build pipeline for this project, we can actually look at that inside of our CodeStar project for our foo project. So here is our build pipeline. If we look at our code build project that is part of build pipeline, we will see here that the build project actually has steps to run npm install as the package manager. Those could be replaced with Maven install or Gradle install as part of the same steps. So same concepts, just different package managers. Thanks for your question.
Anybody else? Any more questions? I think we're good.
Great, thank you. Thank you so much for coming.
Thank you, Sam. Thanks, everybody.